To solve this problem, we're going to solve it as if it was an equation, so if this was an equal sign. And then at the end, we're going to do something different. So if that was an equal sign there, we would need to have everything on one side and set it equal to 0. Well, we're going to do the same thing here where we want 0 on one side and everything else on the other side, and then we're going to factor it. So we're going to go ahead and factor. Since this is a trinomial, I'm going to use the AC method. So I need to think of what multiplies to -6 and adds or subtracts to 1. So numbers that multiply to 6, but they have to multiply to -6, and they have to add to 1. So if I made this a -2 and the 3 a positive, they would multiply to -6 and add a 1. So I'm going to go ahead and put a -2 here and a +3 here. Okay, so here's where we have to do something different. We're going to take a number line and we're going to, if we were to set each of the parentheses equal to 0, now notice it's not equal, it's an inequality, but we would get x equals 2, and then if we take the x plus 3 and set it equal to 0, we would get x equals -3. So we're going to plot these numbers on our number line. We're going to put -3 first because the numbers on the left are smaller than the numbers on the right. And these are going to be our boundary numbers. So now what we have to do is we have to plug in a number that's in between. So we need test numbers. So for example, I need a number that goes over here on this side of the number line. So I'm going to use, let's say, -4. Okay, then I need a number that goes in between -3 and 2, so like 0. And then I'm going to pick a number that is on the right of 2, so something bigger. So I could pick like 4, let's say. Or I'm going to go with actually 5. Okay, but it doesn't matter. So those are going to be my test points. If I plug in numbers in those parts of the graph, the -4, the 0, the 5, if I plug it back into the original problem and it works, then I know to shade that area. So let's go ahead and do that. Okay, so let's go ahead and begin, and let's check if numbers on the left side of -3, so smaller than -3, would work. So I'm going to use an example. A number less than -3 would be like -4. So I'm going to test if -4 would work in the original inequality. So I'm going to plug in a -4. Remember, when it has an exponent, I need parentheses. And I could put parentheses here as well if I want to, but I have to have it if it has an exponent like here. Okay, so then I plug it in. And we get 6. Is 6 less than 0? So remember, this looks like an L for less. Is 6 less than 0? No. So what that means is that we are not shading on this side. Okay, so now let's go ahead and plug in 0. Let's see if 0 works. So we plug in a 0, and we get -6 is less than 0. Yes, that's true. So what that means on our graph here is we are going to shade this section right there. So now we have one more to check. Let's go ahead and check 5. So we have 25 plus 5 is 30. 30 minus 6. 24 is 24 less than 0. No. So that means that we have not shaded. Okay. Now, remember that on our boundary numbers, we need either parentheses or brackets. So since this here does not have the line underneath, so it doesn't have this line underneath it here, that means we're going to use parentheses here. So our answer would be in interval notation, x is any number in between -3 and 2, but not including -3 and 2. Or we can write it in set builder notation like this, that x is a number in between -3 and 2. So your choice whether you want to write it as an interval or if you write it as a set builder. That's the proper way.